So lesson 7-4 is about the areas of trapezoids, rhombi or rhombuses, and kites. The mandatory part of the notes is just make sure you actually get the formulas written down. Whenever you have a formula for area, you should always include a diagram. So we'll start with trapezoids. Remember that trapezoids have one pair of parallel sides. It's really important to understand that the two parallel sides are called bases. It doesn't matter whether those parallel sides, and we usually name them base 1 and base 2. It doesn't really matter which you call which. If the parallel ones were sideways, those would still be the bases. So when we talk about bases, we're not talking about top bottom, we're talking about the two parallel sides. Between the two parallel sides, you could put the line wherever, but a perpendicular line between the two bases is referred to as the height. So if the bases are going side to side, then the height is on the side. So that's really important to understand what's a base and what's a height. So the area of a trapezoid, and there's lots of different ways to do it, is the average of the two bases, which is the same as base 1 plus base 1. Base 1 plus base 2 divided by 2, that's what that 1/2 is, times the height. I'll do an example later, but there's your trapezoids. Trapezoids, the two parallel sides are called bases. You just name them base 1 and base 2. It doesn't matter which one's 1 and which one's 2. And the area is half of the sum of the bases, which is basically the average of the bases, times the height, and the height is the distance between the bases. The height must be in altitude. It must be perpendicular to both of the bases. The other shapes that we're going to do actually have the same formula. If you have a kite, right, and a kite, those two are the same, right? Consecutive pairs are congruent of sides, or a rhombus. A rhombus is a special type of kite in which all four are the same instead of the two being longer. For both of these, the area is 1/2 d1 times d2. So what do I mean by d1 and d2? Well, the d stands for diagonal. So that would be d1 all the way across. I should probably put that in the same color so it's more obvious, sorry. D1 is this distance all the way across, you could call D1. And then you could also put a line that crosses through the other way, and that would be diagonal 2. It doesn't matter which one you call D1 and D2 because you're multiplying. Once again, one direction is D1, and the other direction all the way through is D2. So in this case, that's my D2 line, but it's all the way across, and this little red line I put in is D1. So those are like the bare minimum of notes that you need for 7-4. The area of the trapezoid with a diagram, the area of, I should label this, these are kites and rhombuses, or you might hear me call them rhombi. That's the way you're supposed to actually pluralize a word that ends in US, is with an I. Like radius, radii, octopus, octopi, rhombus, rhombi. So kites and rhombus is half of the product of the diagonals. Area of the trapezoid is half the sum of the bases times the height. So for other notes, I just want to do a couple examples. I'll do like an easy example where they give you the information and one where they don't. So I'll start with just a regular old trapezoid where they give you all the information that you need. So we'll say the bottom of this is 8 feet and the top of this is 6 feet, and that the height is 5 feet. It is a trapezoid, so these two guys are parallel to each other. So the area is the average of the bases, which is 7. Do you see between 6 and 8 is 7? I'm going to go ahead and write it out. The average of the bases times the height. So 7 times 5 is 35 square feet. When you have all the numbers, it's pretty easy to do. What they're going to do a lot of times in the problem is give you enough information to figure out all of the numbers, but to not actually give you all the numbers that you need. So, for instance, here's my trapezoid. This is called a right trapezoid because it has a little right angle in it. And they tell you this is 60 degrees, the top is 5 meters, and the bottom is 7 meters. Well, how is that going to help me? Whenever you see an angle, like 60 degrees, 30 degrees, or 45 degrees, they're referring to those special triangles. So I'm going to cut off a special triangle. So I'm going to make this special triangle, and I'm going to solve out the special triangle. I'm going to redraw it over here. The kind of weird thing about this special triangle is it appears that I don't have any information, right? I can't do anything with just an angle, so I need to look at the picture a little more. If the entire bottom of the triangle is 7, and the top part of the triangle is 5, sorry, of the trapezoid, the bottom of the trapezoid is 7, and the top of the trapezoid is 5, that means this little tiny section right here has to be 2 meters. With that, I'm able to figure out my triangle. So this special triangle is x, 2x, and x root 3. If my short leg is 2 meters, that means the long leg is 2 root 3 meters, and the hypotenuse is 4 meters. So I can add that in over to my drawing. I now know that this is 2 root 3 and the hypotenuse is 4. With this information, I can finally solve out my area of my trapezoid. So, by the way, the 4 is extra information. I don't need it because the area of the trapezoid is 1/2 the bases times the height. The average of 5 and 7 is 6. The height was 2 root 3. So I get 12 root 3 square meters for the total area. Okay, so now on to the other formula. I'll give you one where they gave us all the information, and then one where they don't. So, kite and rhombus, they both have the same formula. So I just happen to have this one. The kite is the one where they give us all the information. So let's see. They tell us that this is 3 feet. The other side is 3 feet. Because of symmetry, those two sides have to be the same. That the top part is 2 feet and the bottom part is 5 feet. So what I actually need to know is the length of this diagonal. So if that's 3 feet and one side's 3 feet, the other side's 3 feet, this total diagonal is 6 feet. Going the other direction, this diagonal is 7 feet. So my area is 1/2 7 times 6. 7 times 6 is 42, and half of that is 21. So the area is 21 square feet. You just need to find the length of those two lines. So what happens? How are they going to do the problems? Well, what they're going to do is they're not going to give you the total length, or they're going to give you the wrong measurements and make you figure out what those lengths are. So in my other example, I'm going to do a rhombus. In the rhombuses, they are more likely not to give you all of the information. There's stuff that you need to remember about the rhombuses. Like in the kite, it was symmetric, so it was 3 feet and 3 feet on both sides of the diagonal. Right, my yellow line up there, 3 feet on both sides. In a rhombus, it's symmetric both directions, so just remember that. Rhombus is symmetric over both diagonals. So let's see. They could do it with a special triangle, where I have to solve a triangle, or in this particular case, they're going to make me use Pythagorean theorem. So they tell me that this is 15 meters, that this little guy here is 12 meters. Well, what does that tell me? I know this diagonal is going to be 24 meters. Why? Because rhombuses are symmetric in both directions. So if one side's 12 meters, the other side has to be 12 meters as well. Another thing true about rhombuses, which is also true about kites, is the diagonals meet at right angles. So I have these little tiny right triangles to deal with all over the place. I need to know the length of the other diagonal, but they didn't give me any numbers on that diagonal. But I do have a right triangle. It's not a special triangle. I don't know the angles in it, but I do know 2 out of the 3 sides. And if I know 2 out of the 3 sides, I can figure out the third side. Remember, the long side is c. A squared plus b squared equals c squared. A squared plus 12 squared equals 15 squared. 12 squared is 144. 15 squared is 225. So I need to subtract to find the other square. I get a squared equals 81. So a equals 9. So this must be 9 meters, which means up in my thing, this is 9 meters, and I know that it's symmetric that direction, which means the total height along that diagonal is 18 meters. Once I have that information, I'm able to find the area. So the area is 1/2 times the product of the diagonals. One diagonal was 24, the other diagonal was 18. This gives me a final answer of 216 square meters. So just remember, sometimes you're going to have triangles that you need to solve in order to have the correct information. For a kite or a rhombus, you need the length of the diagonals. For the trapezoids, you need the length of the 2 bases plus the distance between them.